Another basic elementary function is quadratic functions. When we talk about the basic elementary functions, actually, we give an example h of x equals x square. This is square function, okay, and its graph is the parabol. We talk about that parabol. Maybe we can write f of x equals x square, and the graph of this parabol like this one. In general, we can define the quadratic function as the following form. Definition. So if a, b, and c are real numbers, with a is different than 0, you will see why a is different than 0. If a is 0, we have a linear function, because then the function f of x equals ax squared plus bx plus c, again this is a standard form. You will see we have a vertex form, etc., is a quadratic function, and its graph is called a parabol. So this parabol is some translated version of the f of x equals x square graph. For example, let's sketch some graph. X squared plus 2, for example. This is the graph of 2. Let's say f of x. F of x equals x squared plus 2. This point is 2. This is x-axis. This is f of x-axis. Here, a is 1, if you look to this standard form. B is 0, and c is 2. If we have some b value, maybe it's not easy to sketch the graph of this type of the functions, but in this course you will learn. So let's give an example. Let's say g of x. G of x is the 3x squared minus 12x plus 14. Actually, it's not easy for me directly to sketch this graph, but from your textbook I will sketch. So this is the our parabol. G of x equals 3x squared minus 12x plus 14. Easily we can say that y-intercept or vertical line-intercept is 14, because for x equals 0 from this equation, if you replace x with 0, you can find 14 value. So this is x-intercept. To find this point, this is the minimum value, okay, vertex, it's called a vertex. We will have some strategy, but you will learn. Now we cannot decide. Actually, it is easy to find this point for us. When sketching the graph, to find the y-intercept and the x-intercepts are very important, okay? For the quadratic function, we have a formula. It's called a quadratic formula to find the x-intercept or zeros of the function, root of the function, okay? So in general, if our function is f of x equals ax squared plus bx plus c, so to solve the equation, ax square plus bx plus c equals 0 equation, we have a quadratic formula. Of course, here if a is different than 0. What is that formula? The roots of this equation are x1 and x2. We have two roots. Minus b minus plus square root b square minus 4ac over 2a. This is known as a quadratic formula. Here provided b square minus 4ac bigger than and equal 0. B square minus 4ac sometimes known as a delta for the equation. Okay, let's talk the properties of the quadratic function. How we can sketch the graph, etc. Quadratic functions and their graph. Many useful properties of the quadratic function can be uncovered by transforming. So f of x equals ax square plus bx plus c. Here a is different than 0. Into the vertex form. Okay, this can be written into the vertex form. So that is standard form. So this function can be interpreted as the following way: a times x minus h square plus q. Why we write in that form? Because we know the graph of the x minus h square from the x square we can obtain, and we can obtain the a times x minus h square graph again from the x square from the x minus h square graph, and we add the key. So again, by shifting to up or down, we can obtain the graph of the this function easily. So if you write this function in this form, vertex form, this is the vertex form. Easily we can sketch the graph, okay? The process of completing the square, you can find this process in the appendix 8.7 in your textbook, okay, is central to the transformation. So we illustrate the process through the specific example and then generalize the result. So on the example I try to explain. So let's write the example. What happened? Oh my god. It is deleted. Okay, so let's write our example. F of x equals minus 2x squared plus 16x minus 24. Okay, this is your from your textbook. This example taken from your textbook. By considering this quadratic function, our aim is to complete the square. So what that means? It easily we can take the minus 2 common factor parentheses. So minus 2 x square. From here we have x square minus 2x square. And if you consider the 16x, because of the minus 2 common factor parentheses, we have minus 8x, okay? So minus 8x, this is the remaining, minus 8x, minus 8x. Now we have the same, this is the same, minus 2x square plus 16x. Okay, minus 24. These are equivalent, there is no problem, okay? Factor of the coefficient of x square out of the first two terms. Now, our aim is to write the x square minus 8x as a square of function, as a square function, minus 8x plus, let's put the question mark here, okay, minus 24. So what I wrote for this question mark, this will be square of the sum terms, okay? So we should add the 16 for the question mark to complete the square inside the parentheses. So it will be x minus 4 square. How we find the 16? 16 is the half of this coefficient square. So half of the minus 8 is 4. So 4 square is 16, okay? So here you should add 16. And when we add the 16, of course, we should subtract the 16. So let's rewrite minus 2 x square minus 8x plus 16. Because of this minus 16, if you multiply minus 2, we have 32. So we should add the 32 minus 24 plus 32. Okay. This 32 comes from this minus 16 times minus 2. This is minus 16, so which is inside of the parentheses. If you distribute this minus 2x squared, that term, minus 16, so 16x, this term, and minus 32, and here we have plus 32. These are cancelled. Then we have minus 24. So again, we have the same equation. So as a result, we obtain minus 2 times x minus 4 square. This is x minus 4 square directly. Let's recall. X minus a square equals x square minus 2ax plus a square, or x plus a square equals, a square equals x square plus 2ax plus a square. So the reason why we divide the 8 by 2 to find the number a, and we have 8x squared to complete the square term. Okay, so here we have plus 8. So plus 8. Plus 8. So we obtain the vertex form. This is vertex form. This is standard form. So from standard form, easily we can obtain the vertex form. From the vertex form, easily you can guess the maximum or minimum value of f of x, okay? How? If x equals 4, here, this is 0. So we obtain this term equals 0. And f of 4 is 8. Okay? For any other values of the x, this is negative because of the this minus 2 factor. This is always negative. For any other values of x, this term is negative. So we subtract some value from the 8. So it makes this value, f of x value, is smaller than the 8. So f of 4, which is 8, is the maximum value. This is maximum value of f of x. If it were positive, it will be minimum value because always you add some positive term to the 8, okay? Furthermore, if we choose any two x value that are the same distance from 4, we will obtain the same function value, okay? So it is symmetric about the x equals 4 line. For example, for x equals 2, minus 2 square 4, minus 8, this is 0. For x equals 6, 2 has a 2 unit between the 2 and 4. So if you go the other direction, for somewhere here 2, so this is 2 distance, so 2 distance, this is 6. For x equals 6, you will obtain the, again this is 2 square 4, 8, so this is 0. So when x equals 2 and when x equals 6, the function value is the same, which are 0. For example, for x equals 3 and x equals 5, each one is one unit from the 4, so same distance. The function value are 6. Okay. Therefore, the vertical line x equals 4 is a line of symmetry. That is, if the graph of the this equation, or this equation does not matter, if the graph of this equation is drawn on a piece of paper and paper is folded along the line x equals 4, then two sides of the parabol will match exactly. Okay, all these results are illustrated by graphing this equation or this equation. The line x equals 4 simultaneously in the same coordinate system, we can show that. So the graph x equals 4 line is this line. This is the 4 x equals 4 line. So we find the maximum value. The maximum value is 8. So when x equals 4, it reached the 8. So this is the maximum point. This is the 8. And we can observe when x equals 2 and 6, this is the 0. Function value is 0. So the graph like this one. Maybe my sketching is not good, but this point is 2, this point is 6. So this is the graph of the R function. What is the y-intercept? I don't know, but in the future we can find. For x equals 0, you can verify easily. For x equals 0, this is minus 4 square, 16. 16, let's calculate here. Y-intercept. For x equals 0, f of 0 equals minus 2, 0, minus 4 square plus 8, 16, minus 32 plus 8, minus 24. So this point is minus 24. So my sketch is not good. Maybe we can resketch this graph, because I know a lot of information now. End of this term, you will be able to sketch the graph of the more complex function, okay? So our graph like this one. So y-intercept is minus 24. If it continues like this one, this point is minus 24. This is the symmetry line, x equals 4, and the x-intercept are 2 and 6. This is the graph of the this function. And from the graph, we can say some things. The domain is all real number. There is no problem. For all x, you can find the y. But the range is y is less than 8. Okay, so the range. So this is the range of this function. Okay, there is no problem for the domain. Domain is the whole x-axis, because for all x-axis you can find. Maybe here you can consider what is the value of the function when x equals minus 2, minus 10, etc. But there are some values. Maybe this is very, very big number in the magnitude, but we have a value you can find. Okay, I know that this section, this record a bit longer when compared to my other videos, but I would like to summarize, okay, for the quadratic function. Given a quadratic function and the vertex form obtained by the completing the square, so you can find ax equals f of x equals ax square plus bx plus c. Here a is different than 0, which equals a times x minus h square plus Q. So by summarizing this vertex form, we can say the following things. According to the sign of the A, if A is positive, the graph is downward, and like this one. Okay, so the vertex, this point is called a vertex, the minimum value is called a vertex, is h, k. Which hk? This h and this k. So because of this reason, this is called the vertex form. Okay, this is the vertex form. And x equals h, this point is the h. So x equals h is the symmetry axis. Okay, when this graph is valid for a is bigger than 0. If a is less than 0, the graph is downward. When a is bigger than 0, the graph is upward. When a is less than 0, the graph is downward. So the graph like that one. What happened? Oh my god. Okay, so the graph like this one. And again, x equals h is the axis, symmetry axis, and this point is h, k. This is vertex. So key value is maximum value. Okay, here key value is minimum value in the first case. So let's write this is key, this is minimum, this is maximum value. Here a is less than 0, the graph is downward. Here in the first case the graph is upward. And always vertex is h, k. Okay, parabol increase on the side of the vertex and decrease on the other, for which case this is increase and decrease for the negative case. Here this is decrease and increase for in that case. So symmetry of the axis is always x equals h, and f of h equals k is the minimum value. This is f of h equals k minimum value. Here f of h equals k is the maximum value.